Hello everyone and welcome back to the channel. This is Pablo VA3HDL, and in this video I will show you what I have here on my desk, the DSP audio microphone processor with preamp and equalizer. So we're going to talk about what it is, why do you may need one, how it works, and difference between analog and digital versions, and how to build one in case that you want to do it. So let's get started. So let me show you the shack a little bit around, and if you have one of these radios, you don't need a preamp for your microphone or an equalizer. Everything you need is already built in the radio. The DSP, the digital signal processing for your audio, is already built in your radio. But I have this other radio, which is a vintage radio from the 70s to the 80s, right? So in this radio, there is no much audio processing power in here, almost nothing. Just you have a drive in there to set up your microphone level, and you have the processor, and it's pretty bad, the processor on this radio. So this is the reason that I built the digital DSP audio microphone preamp and equalizer. So let's jump into the details of the unit. This is also other reason that I wanted to use a preamp is I want to also replace this microphone. This is the original microphone that came with the unit, and it works fine, but it doesn't. The radio is a 100 watts radio, but with this microphone, it's very hard to get the full power out of that radio. So that it was another reason that I wanted to build the preamp. So I looked around, and what I found is this book. This actually is an ARRL book. It's Microcontroller Projects for Amateur Radio, and it's a very, very nice book. On the chapter 12, it talks about how to build a unit like this one. Even in the page of the book, they show this similar project to mine. You can see here is using the same components. Is using the like a baseboard for all the connections, like I did. In the middle is using the Teensy 4.1, and on the top is the audio shield for the Teensy, which is what I also use, and you will see it later. So when looking at this chapter of the book, the chapter 12, they talk about the digital signal processor audio microphone processor. And so what this audio mic processor can do is it has aromatic speech compressor, it has a multi-band equalizer, it has FFT display or spectrum display, which I will show you, and you can interface with the same connections, both dynamic and electric type of microphones, to an older transceiver like the FT757 that I show you that I have. So, like I said here, there are several commercial units I found. They were priced around $200 US, and the parts that I purchased to build this, it cost me around $60 Canadian, which is more or less $40 US. Okay, before I power up the unit, let me first give you a tour of the connections. So here it has an OLED display. It has an encoder with a push button to select the options on the screen. On the left side, it has the majority of the connections. This is for the microphone input. This is headphones connection. If you want to monitor your in real time with no delay your audio from the microphone, you can do it connecting a headphone in there. Here is the USB connection, the micro USB connection for programming through the computer. You don't need this when you're using the radio. And in here you can power the unit with 13.8 volts or lower. It has, I'm going to show you, I put inside a voltage regulator. In the back of the unit is only the output of the microphone that it goes into the radio. And for that, what I did is I use the same cable that came with the microphone that I purchased, which is this one here. So this microphone I ordered from AliExpress, and it came with the same connector that my radio uses, the FT757D uses. So what I did is I cut the cable, and in the part that I cut, I place two RG45 connectors. And I place the connections in the same order in both sides, so to avoid any confusions, the order of the connections are the same on both sides, and it's also the same on the connector here on the microphone in this plug. Same order. So now let's fire the unit up and let's go through the options. Now it's booting. You will see later, I will show you the insides. It has an SD card, and I'm using the SD card to save the settings. So the main menu, it has the following options: spectrum display, volume levels, equalizer configuration, equalizer on off, you can turn it on from here, compressor configuration, compressor on and off, input, could be mic or line. I just have a connection for microphone, but you can also add a secondary line input that you can use to connect your computer, for example, to do digital modes. And the SD card menu. And it will go back to the first part. So if I go inside here, it's not going to show much because this is noise. It has no microphone connected, but then we will do a test with the microphone on. But this is the spectrum display. So volume levels, it has headphone output level, line in, which is 0 because I'm not using it. Line out, which is what is the connection going into the FT757, the connection going to your rig. And that's it. You can go back to the previous menu. In the equalizer configuration, the equalizer has 8 bands that you can tweak on the code. Those are common bands. By the way, now I'm talking about the code. I use as a base the code on the book, but I rewrote at the end the code. Probably around 90% of the code is rewritten because I'm using different screen. I am using a different encoder, and the original code use a touch screen. So you can see it has 150 hertz band, 240 hertz, 370 hertz, 600 hertz, 900 hertz, 1.3 hertz, 2.0 hertz, 1.3 kilohertz and 2 kilohertz, and 3.3 kilohertz. So this band, they have a little bit of overlap between them, so it's not perfect. So, but at the end, you can tweak up and down, plus or minus 12 dB each band. Here, if you push the button, you turn the equalizer on or off, just to see how that sounds. Your setting, you can do that test. The compressor, it has the compressor gain, that it has preset values of that every time you push, it changes 0 dB, 6 dB, which is where I use, and 12 dB. I'm gonna put it back to 6 dB. The response time is how fast the compressor reacts to adjust the volume is 25 milliseconds, and it has preset values of 50 milliseconds, 100 milliseconds, 0 milliseconds, or 25 milliseconds, which is the setting that I use. The hard limit is how you're going to use the compressor. You can use as to level the volume up or down, or you can use just to use as a limiter, right? And to use as a limiter, you need to turn it on, this option on. The next option is the threshold, is minus 18 dB. So anything that is below minus 18 dB is going to try to increase the volume up to minus 18 dB. The attack is how fast the volume is going to increase, right? So it's half dB per second, the speed, right? And in the decay is 1 dB per second. So this is how fast the volume is gonna go back to the normal level. And here you have also the microphone gain, which is I have it set at 35 dB. And then you can go back. Then you can turn on the compressor and off to see how that works for you. And like I said before, you can select your input line or microphone. And the SD card menu, it has three options. Delete the settings, read the current settings, or save the settings into the SD card. Or you can also simply go back. By default, when you boot the unit goes and reads the settings from the SD card. But if there are no settings file on the SD card, it loads default settings from the programming. That basically covers the menu. So next I will show how it works. Okay, in this part of the video, we're gonna test the preamplifier. So I connected the microphone here, the microphone that I showed before, the knockoff for the Yesu replacement, and the yellow cable here on the back. This yellow cable here on the back is connected to the computer. And to do the audio test, what I'm going to do is I'm gonna mute this microphone that I'm using right now. And I'm going to start using the microphone connected to the preamp. So you're going to see that when I'm doing that on the software that I'm using for mixing on the computer. Let me bring this up. Okay, now we have the mixer on the screen, and I'm using the microphone, the Logitech microphone, which I'm going to mute now, and I'm going to unmute the microphone connected to the preamp. So I increased the gain of this microphone here to make it closer to the gain that I have from the studio microphone that I was using before. So you can still have the same level of audio while we go through the demo of the settings on the preamplifier. Okay, the compressor is now off and the equalizer is off, and let me go through
the spectrum display. So now the spectrum display is on, and you can see on the top there is a peak meter in yellow. When there are peaks, the yellow bar moves to the right. And at the bottom, you can see the spectrum analyzer with all the different bands, like any other spectrum analyzer. That spectrum analyzer is connected at the output of the mixer. But in the peak meter here, the yellow one, there is two bars, one on top of each other, and there is not enough resolution on the camera to make a difference in between the two bars. I don't know if you can see when I'm talking, the two bars move at the same time. Also, the other reason that the two bars move together at the same time is because the input and the output now is mainly not disturbed. Is almost the same because equalizer and compressor, they are both off. Now we're going to turn one at a time. We're going to turn the equalizer first on. So let me go back to the menu and turn on the equalizer, and you will hear the difference on the audio. Now the equalizer is on. So it should be, I cannot hear myself, I cannot monitor myself because of the delay, but you should be able to hear the difference with the equalizer on and off. And I'm gonna turn the compressor on also. Now the compressor is on, and I will go back and show the spectrum display again. So now it should be, yeah, you can see here the different peaks between the input and output. So the input is the top yellow bar, and probably it's very hard to see in your screen, but below is a shorter one, which is the output, where the volume of the microphone is getting normalized by the compressor. That prevents the radio to be saturated, right, like overdriven. Number one, and number two, allows also to increase the low part of the modulation and make it more even. Next is a test that I done on the radio itself, and you will see the results from transmitting on the FT 757GX and receiving the audio unprocessed by the FT991 alpha that I was showing earlier. Now with this, in this final test with the radio, what you can see on the screen is on the bottom left corner, you see the FT991 alpha that is receiving the signal from the Yaesu FT757GX that we have the preamp with the equalizer connected on. So the audio is coming directly from the FT991 alpha into the PC and is unprocessed, and you can see in the screen, in the top of the screen, the output directly from the FT990 alpha, and the spectrum analyzer, the frequencies that is producing the FT757 with the equalizer right on the correct frequencies for radio.
Okay, this is the end of the part one of this video. If you like it, please remember to subscribe and click the like button down below. And stay tuned for the part two, where I'm going to show how I put this pre-amplifier together with details explanations. Thanks for watching, and until the next time.